Hello everyone. In this video, we will understand the Snowflake architecture. In the previous video, we understood what is Snowflake. So in this video, in the part 2 of the section, we'll understand what is Snowflake architecture. So let's jump in. If you ask me to pick three things why Snowflake architecture is very good, I would recommend these three things: scalability, performance, and cost efficiency. Snowflake is actually called a shared nothing architecture. There is nothing is shared in the architecture. But what does this mean? To understand this, let's understand the traditional shared disk architecture. How does a traditional architecture work? Let's say in a traditional architecture where all the resources are shared. Imagine a big box of resources which needs to be shared. We have a process one running, then query two, three, four, and all of a sudden, a whole system goes slow when a big unknown, wrongly written, or correctly written, in fact, you never know, but big query 5 comes into the picture. And because of that, all the resources have become slow. This is the downfall of the architecture in a traditional methodology. And Snowflake has converted to this, Snowflake has converted to their advantage. They have seen these problems in the traditional architecture and have created an architecture which is, let me actually jump in. So rather than all 5 queries running in the same box, Snowflake executes them parallelly. So something like this. So your one, your two, your three, four, and five, even irrespective of their sizes of the queries, are running parallelly and there is no shared box. What is this called? This is called, so first of all, what is happening? No sharing is happening because every particular query or a process is running individually on their own. There is better performance, scalability. This is called MPP, massively parallel processing architecture in Snowflake. This is a very important thing if you're trying to prepare for Snowflake interview and questions. So that's one of the very common pieces, like what is massively parallel processing. So this is how you're processing your queries. Let's take an example. This is the same example I've explained before, but this makes very sense here. Let's say you have a data set with 10,000 rows, P1. Then you have a data set with 100,000 rows, P2. And then you have a last one with 1 million rows, P3. How do we know? Let's understand how the process in Snowflake works. Let's spin up virtual warehouses. A small one for P1, a medium one for P2, and a large one for P3. So all three are physically separated, but take the same time and finally are logically integrated into a database because they have a different virtual warehouse being launched. For 10,000 rows, we launched small. For 100,000 rows, we launched a medium warehouse. And a million rows one, we launched a large warehouse. The amount of time the small warehouse took and the large warehouse took is the same because, and the cost is also efficient because in the if you have not watched my previous video, go watch that video where I explain that it's like every 60 seconds is what Snowflake charges us per minute. So your 1 million rows, if you take a larger warehouse, it takes only 1 minute to run. So based on that, so it's very powerful. As you learn more, you'll understand more about this. And I'm going to put more videos about virtual warehouses. That's my exact plan next week. So now let's jump into different techniques. Like if you ask me, we understood the architecture, what is shared nothing, what is the traditional architecture. But let's say if you get, again, same three things. If you give me three important things about the Snowflake architecture, what I like about entire Snowflake mechanism. Say, when you submit a query, Snowflake checks to see if that query has been previously run. If that query has been previously run, it checks in the database if there is a cache on top of it. And Snowflake will use that cached result set if it's still available rather than executing the query you just submitted. So these is convert. I mean, it saves our resources. It saves money because there, if I said select star from a table name, and if that data is already stored in Snowflake cache, it comes faster because the data is in the cache already. Not like every time when you select star, when you do that select star from query, it's going into the data warehouse or database and getting the database and giving. No, it's stored. So caching is a big thing. So you reuse what is available, saving the resources and also faster processing. So there are three Snowflake caching types. One is the query results cache, virtual warehouse cache, and metadata cache. We're going to talk more about this in our future videos. And if you want to know more about this, do comment. I'll probably make separate videos, any specific topic you want to do. The other part, what I like is the zero copy cloning. I don't know if you have heard about zero copy cloning, but this is a fantastic thing. So zero copy cloning offers the user a way to snapshot a Snowflake database, schema, or a table along with its associated data. What does this really mean? So let's say you had a database and something happened and you want to clone into another database. Let's say I have all the employees in a big table or a let's say entire human resources data schema is available and nothing changes. You just want to clone it because you want to reuse it. There is a feature called clone in database of Snowflake where you can completely copy everything, but you do not pay anything. There is no additional storage charge until changes are made to the cloned object. What does that mean is, let's say if database 1 has 10 columns and the database 2 has 10 columns and nothing has changed, no, not much has changed. So to clone exactly the same thing, no charges, you can clone it. So everything works perfectly. Somebody is This is primarily used for your dev and stage kind of testing. Your dev uh, teams would and test teams, generally somebody is developing something, you would like to exactly in your test environment everything should be the same for your testing to run properly. So there are many uses for zero copy cloning, um, creating backup, but most oftenly it is used to support your dev and test environments. Remember one thing, zero copy cloning is a metadata only operation. It's basically copying your metadata, but it's a big money saver. Now, let's say time travel. This is not the time travel where you go into 50 years back, 70 years back and change something in reality, but actually, Snowflake is doing that. So, something is like time travel allows you to restore a previous version of a database table or a schema. Let's say for some reason you dropped a database, knowingly or unknowingly, and you need that now. How? Snowflake lets you do it. So you deleted that particular. So, and that particular database was snapshotted somewhere in Snowflake. You can restore it and run SQL and do your operations on top of it. This is such a powerful tool. You have caching, you have time travel, you have cloning. It's highly scalable, performance and cost efficient. Snowflake is something which I would suggest everybody to start learning. So thank you. Thanks a lot for watching this video. Do learn Snowflake. Sorry. And if you like our videos, please do subscribe to our channel. In the future, I'm planning to make more videos on Snowflake virtual warehouses, interview questions, and my feedback on a book which I'm reading. So see you later. Thanks a lot. Have a great time.